In this video, I want to describe the benefit of call by reference in the context of C++ and object-oriented programming. In the previous video, I described pass by reference as a review for what you did in C, where I described these variables that these lines presented the address and value of those variables, and this pass by reference you had to use the ampersand in order to pass the address within these pointers. So what is the purpose of call by reference and what's it benefits to you in object-oriented programming? The call by reference is where we used an ampersand in the function call instead of a pointer. So what we're doing is we're still passing a pointer, but we're treating the pointer as a C++ object. So what does this allow us to do? Notice how in main that if I want the address, I put an ampersand in front of the variable, and if I want the value, I do the same. In C, in order to do it procedurally, we had to do all these addresses and pointer stuff. In C++, what I can do is I can say, instead of a star, I want to put an ampersand there. This allows me to do an input. I can also make changes in call by, but when I want to actually get the values, it's simpler. And so why is that? Notice how if I want the address or the content of the registers for call by, I do it in the exact same way that I do it in main. Likewise, if I want to get the values when I use call by reference, I do it the exact same way that I do it in main. So the objective here is to get those values in a more consistent manner. Now, if you understand what's going on underneath the hood with the procedural and imperative programming, it makes doing call by reference and this object-oriented programming a lot easier because you understand what's going on and you understand the benefit. So based on this, our theory is that the address here that we'll print out, this address in call by reference, and the content of the register here at line 6 in pass by are going to be the same. Likewise, the values for call by reference versus pass by reference are shown here. We're not going to have the address of the register pointers. Tend to think of call by reference as a middleman. We want to cut out the middleman and be able to get these values and make the changes. So let's run the code and see what happens. So here are the values. You see that 408 and 40C are the address. The content of the register pointers, those are the same values. And the content of the register pointers in call by, those are also the same values. So we see that what we predicted came to pass. So now let's see what we would have to do if we wanted to change the values in pass by. So pass by, I would have to do star input 1 plus equals 10, right? And if I wanted to make a change here, I don't have to dereference it because I've cut out the middleman. So I can say input 2 plus equals 20. And then I can make a change here by taking these two values at the end and calling this main after and values in main after. And then we can run the code. And we see what happens here. In pass by reference, I had to dereference it in order to update the value. In call by reference, I don't have to physically dereference it because since C++ is treating it like an object, it's doing the work for me. Therefore, what we initially have in pass by is we're adding 10, so this becomes 0, and here we're adding 20, so this becomes 42. We see that the addresses remains the same throughout the entire process, so we see that the initial address and the final address in main are the same, but then we have 0 and 42 as we predicted. So the benefit of call by reference is to be able to make these changes without having to do excessive procedural dereferencing.